This process begins quietly at the source, as daylight slowly spreads across vast papaya plantations, and harvesting starts only when the fruit reaches the precise level of ripeness required for industrial processing. At this earliest stage, timing defines everything. Fruit harvested too early lacks stability during transport and processing, while fruit harvested too late becomes difficult to standardize and handle at scale. What unfolds here is not speed, but precision repeated thousands of times across the fields, day after day, season after season, forming the foundation of the entire operation. Each papaya is picked by hand, one by one, using controlled and deliberate movements designed to protect both the surface and the internal structure of the fruit. This careful handling is intentional. In large-scale food production, quality is not created by machines, it is preserved long before automation begins. Across the plantation, teams move steadily along the rows, repeating the same motion hour after hour, ensuring uniformity at a scale that cannot rely on chance, improvisation, or individual judgment. As harvesting continues, the fruit is placed into containers and staged for transport. Refrigerated trucks stand ready nearby, because temperature control begins immediately. Cooling slows natural degradation and stabilizes the papayas during their journey from the fields to the processing facility. This stage may appear simple, but it quietly determines how well the fruit will perform in every operation that follows, from washing to cutting to preservation. During transport, logistics becomes an extension of quality control. Routes are planned carefully, timing is monitored continuously, and refrigeration remains constant. The objective is consistency. The fruit must arrive in the same condition in which it left the field, regardless of distance, traffic, weather, or volume. Every minute and every degree matter. Small deviations at this stage can multiply later in the process. When the trucks arrive at the facility, the operation shifts from agriculture to automation. Vehicles move into automated receiving bays where human handling gives way to engineered systems. Entire trailers are gently lifted and tilted, allowing thousands of papayas to flow steadily into the processing line. Gravity replaces manual unloading, reducing impact, minimizing damage, and maintaining a continuous flow from the very first industrial step. This moment marks a clear transition. Individual fruit becomes part of a continuous stream. From this point forward, the process is designed to never stop. Instead of batches, the factory operates as a flow, where each papaya follows the same path, under the same conditions, at the same pace. Continuity becomes the defining principle. Inside the factory, the fruit enters water-based transport channels known as flume systems. These channels guide the papayas forward using controlled water flow rather than mechanical force. At this scale, even minor impacts can accumulate into losses, so movement is designed to cushion, not accelerate. The fruit remains suspended, separated, and in constant motion, avoiding direct contact with hard surfaces that could cause bruising or structural damage. As the flume system carries the papayas deeper into the facility, the first stage of cleaning begins. High-volume water removes soil, dust, and field residue accumulated during harvesting. This washing process is continuous and uniform. There are no pauses, no exceptions, and no shortcuts. Every fruit receives the same exposure, regardless of position on the line or speed of movement. Hygiene here is not treated as a single checkpoint. It is embedded into the rhythm of the entire operation. Water flow, pressure, temperature, and exposure time are carefully regulated to balance cleanliness with preservation. The goal is not to alter the fruit, but to prepare it, removing only what does not belong while maintaining its natural structure. While the line continues uninterrupted, thousands of papayas pass through this initial cleaning stage every minute. Nothing waits. Nothing stops. This constant motion is intentional. In large-scale processing, stability comes from repetition, and repetition depends on uninterrupted flow. Any interruption at this point would ripple across the entire facility. By the end of this phase, the papayas have completed their transition from open field conditions to a controlled industrial environment. They are clean, stabilized, and aligned within the system, fully prepared for the more precise inspection and sorting operations that will follow next. Inside the facility, the papayas enter water-based transport channels known as flume systems, where controlled water flow replaces mechanical force. Instead of being pushed or carried on belts, the fruit is gently guided forward by moving water. This approach minimizes impact and reduces surface damage, which becomes increasingly important when thousands of units move through the line every minute. Watch how the papayas remain separated and suspended, never colliding aggressively, always moving as part of a controlled stream. As the flume system continues, the washing process intensifies. High-volume water jets remove remaining soil, dust, and organic residue that could interfere with later stages. This washing is continuous and standardized. There are no pauses or individual adjustments. Every papaya receives the same exposure, the same pressure, and the same contact time, ensuring uniform cleanliness across the entire flow. At this scale, hygiene is not treated as a single step. It is embedded into the motion of the line itself. Water temperature, flow speed, and filtration are constantly monitored to maintain consistent conditions. The objective is not to scrub the fruit aggressively, but to clean it thoroughly while preserving its natural structure and surface integrity. As the papayas leave the washing channels, they transition seamlessly into inspection zones. Here, the pace of the line does not slow. Instead, advanced optical systems take over the task of evaluation. High-speed cameras capture multiple angles of each fruit, while sensors analyze size, shape, and surface condition in real time. Decisions that would take human inspectors several seconds are made instantly. Every papaya is assessed individually. This is not a sampling process. It is total inspection. Software compares each fruit against predefined quality parameters, identifying defects, irregular shapes, or surface damage. Notice how this evaluation happens silently, without stopping the flow or interrupting the rhythm of production. When a papaya fails to meet the required standards, it is automatically diverted from the main line. Mechanical gates and directional systems guide it away with precise timing. There is no hesitation and no manual correction. Approved fruit continues forward, while rejected units are removed without affecting the rest of the stream. This automated triage is critical for maintaining consistency downstream. By separating unsuitable fruit early, the system prevents waste from spreading into later stages, where processing becomes more complex and resource-intensive. Quality control here protects both efficiency and product integrity. As the inspection and sorting process continues, the line remains in constant motion. Thousands of decisions are made every minute, each one reinforcing the same standards. Across the facility, similar inspection systems operate in parallel, ensuring that every section of the flow follows identical rules. If you look closely, you can see how repetition becomes reliability. The same actions occur again and again, not because the process lacks flexibility, but because consistency at scale depends on it. This is where automation replaces subjective judgment with measurable criteria. By the end of this phase, the papayas that remain on the main line have been washed, inspected, and approved. They are uniform in condition and aligned within the system, ready to be directed toward their final processing paths. From here, the journey begins to split, as different products require different transformations. After inspection and sorting, the process begins to divide according to the final destination of the fruit. Some papayas are directed toward canning operations, while others continue toward liquid processing. This separation happens seamlessly, guided by earlier quality assessments and system logic, without interrupting the steady rhythm of the line. In the canning area, precision becomes the dominant theme. Papaya pieces are portioned and placed into cans with consistent accuracy. The movement is repetitive and controlled, designed to ensure that every container receives the same quantity and arrangement. At this scale, uniformity is essential, not only for appearance but for thermal processing that follows later. Once the fruit is in place, syrup is added in carefully measured amounts. Flow rates are calibrated to maintain balance between flavor preservation and structural stability. Immediately afterward, lids are applied and sealed, creating an airtight environment inside each can. This sealing step marks a critical transition, as the product is now isolated from external conditions. Sealed cans move directly into pressurized chambers known as retorts. Inside these chambers, temperature and pressure are tightly controlled. High-pressure steam circulates throughout the vessel, transferring heat evenly to every can. This stage is invisible from the outside, yet it defines the shelf life of the product. Sterilization eliminates microorganisms and ensures long-term stability. The retort cycle follows precise timing. Too short, and safety is compromised. Too long, and texture and flavor are affected. Sensors continuously monitor conditions, adjusting pressure and temperature to maintain exact parameters. When the cycle is complete, the chambers gradually depressurize and open, allowing the processed cans to exit in a controlled manner. At this point, the transformation from fresh fruit to shelf-stable product is complete for the canned line. The cans move onward for cooling and handling, while attention shifts to a different part of the facility where other papayas follow a separate path. In the pulping area, peeled and prepared fruit enters industrial pulping systems. Centrifugal force breaks the papayas down into a smooth, uniform mass. This process is continuous, designed to handle large volumes without interruption. The goal is not speed alone, but consistency across the entire batch. Throughout pulping, sensors monitor texture, temperature, and flow rate in real time. Any deviation triggers adjustments that keep the output stable. Automation replaces subjective evaluation with constant measurement, ensuring that the first liter of pulp matches the last. The pulp then moves into large blending tanks. Here, formulations are prepared and powerful internal mixers operate at controlled speeds. Ingredients combine evenly, and the mixture circulates continuously to prevent separation. This stage emphasizes repetition and balance, reinforcing uniformity through motion. Once blending is complete, the mixture undergoes homogenization. High pressure forces the liquid through narrow channels, breaking down remaining particles and stabilizing the structure. The result is a smooth, consistent product designed to maintain its texture during storage and transport. By the end of this phase, the papaya has been transformed in two distinct ways. One stream has become a sealed, shelf-stable product, while the other has been converted into a uniform liquid base. Both outcomes depend on the same principles: control, repetition, and precise coordination at scale. After homogenization, the liquid papaya base moves into bottling lines, where the pace of the operation remains steady and controlled. Rotary filling systems dispense exact volumes into each container, maintaining uniformity across thousands of units per hour. Every motion is synchronized, ensuring that bottles are filled consistently without splashing, overflow, or interruption. Caps are applied immediately after filling, sealing freshness inside each bottle. This step happens in a fraction of a second, yet it is essential. Once sealed, the product is protected from external contamination and environmental exposure. Robotic arms take over handling, gripping, and placing bottles with precise alignment while maintaining a continuous flow along the line. As bottles advance, automated systems group them for case packing. Each unit is positioned accurately into cartons, reinforcing consistency not only in the product itself but in how it is prepared for transport. Packaging here is not decorative. It is structural, designed to protect the contents during movement, stacking, and storage. The filled cases move onward to palletizing zones, where robotic systems stack layers with consistent spacing and alignment. Pallets are built according to predefined patterns that balance stability and efficiency. Every layer reinforces the structure below it, ensuring that the load can withstand transport without shifting or collapse. Once palletized, automated vehicles transport the finished loads into organized storage areas. These vehicles follow mapped routes, guided by sensors that monitor position, spacing, and speed. Human oversight remains present, but direct handling is minimal. At this stage, the process is governed almost entirely by coordination between machines. Inside storage zones, pallets are arranged systematically. Inventory is tracked digitally, allowing precise control over location and movement. This organization ensures that products can be dispatched efficiently, responding to demand without disrupting the flow inside the facility. Across the factory, production continues without pause. Lines run in parallel, systems repeat the same actions, and monitoring never stops. At this scale, reliability comes from repetition. Every step reinforces the next, creating a process where variation is gradually eliminated through control and design. As finished products leave the facility, the journey reaches its final stage. What began as fresh fruit in open fields has passed through a coordinated sequence of mechanical, thermal, and logistical systems. Each transformation was guided by the same principles: precision, consistency, and scale. If you find these industrial journeys interesting, consider subscribing to explore more behind-the-scenes processes like this one. From field to factory to final distribution, these systems quietly shape the products we encounter every day, long before they reach the shelf. Gear unico audio novamente. Neo altir velocidade/pausas. Mini bloco final, texto continuo. Across operations like this, what stands out is not any single machine or step, but the way continuity is maintained from beginning to end. While individual systems handle specific tasks, the facility functions as a single coordinated organism, where timing, repetition, and control are carefully aligned. Even small variations are absorbed by design, allowing production to continue without disruption. As the line runs, monitoring never stops. Sensors, controls, and automated feedback systems constantly adjust conditions to keep output stable. This quiet oversight is what allows large volumes to move with precision, ensuring that consistency is maintained not just for minutes or hours, but across entire production cycles. What began as fresh fruit in open fields has now passed through a sequence of processes designed to transform natural variability into predictable results. Each stage builds on the one before it, reinforcing quality through repetition rather than force. By the time products leave the facility, the complexity of this journey is no longer visible, but it is fully embedded in the final result. If you enjoy seeing how everyday foods are produced at scale, consider subscribing for more behind-the-scenes journeys like this one. From field to factory to final distribution, these systems operate continuously, shaping what reaches shelves around the world long before consumers ever notice.